In this video, we're going to look at the derivatives of sine, cosine, and tangent, and how we can use that in conjunction with the power rule, and the product rule, and the quotient rule, and the chain rule. So, you should know that the derivative of sine x is cosine x, the derivative of cosine x is negative sine x, and the derivative of tangent is secant squared x, a little bit different. These need to be memorized. A good little memory trick for at least the sines and the cosines is to write them. So if you write sine x, you know that its derivative is cosine x. Cosine turns to negative sine x, and that means negative sine x turns to negative cosine x. So if you list them out, sine, cos, negative sine, negative cos, you can read down the chart. So if I need to find the derivative of cos x, it's going to be negative sine x. If I need to find the derivative of negative cos x, it's going to be sine x. Derivative of sine is cos, and so on and so on. So that's a good little memory trick people like to use. So let's look at example 1. Y equals cosine of x squared. So this is actually going to involve the chain rule because we have the function x squared inside the cosine function. So we're going to start the derivative. We're going to start by taking the derivative of the outside function, which is the cosine. So cosine, the derivative of cosine, is negative sine. And just like any other chain rule problem, you're going to leave the inside function alone. And then you're going to say times the derivative of the inside function. The derivative of x squared is 2x. And generally people would write this negative 2x sine of x squared, but you don't have to. So what is the difference between example 1, cosine of x squared, and example 2, cosine squared of x? If you see the squared in between the cosine and the x, that really means that the entire cosine of x function is being squared. So you may want to rewrite that like I just did with the parentheses around the cosine and the squared at the top. And so that makes it a little more obvious that this is also a chain rule problem. But this time, the squared is the outside function. So I'm going to start by doing the derivative of something squared. And the derivative of anything squared is bring down the 2, keep the inside, and the new power becomes to the 1. Obviously, you don't have to put the 1 there. And then you're going to times this by the derivative of the inside function. And this time, the cosine x is the inside function. So the derivative of cosine x is negative sine x. And again, you would probably see this written as negative 2 sine x cosine x, but it doesn't have to be rewritten this way. Okay, the next example we're going to look at, number 3, 1 plus tan t over 1 minus tan t, is clearly going to involve the quotient rule because we have division. So our top function is our f, our bottom function is our g. So let's list out our f and our g. And let's take the derivatives of f and g. So f prime, 1, it goes to 0, and tangent is now going to go to secant squared of t. Same thing with g prime, 1 goes to 0. Negative tangent is going to go to negative secant squared of t. And so we're going to set up our quotient rule. F prime times g, and I'm going to use parentheses here because it's 1 minus tan t. There's more than one term here. Minus f times g prime, all over g squared. And again, with quotient rule, we're going to need to clean up the numerator. We're not going to worry about the denominator so much. So if you notice, in the denominator, both terms have a secant squared, t, so I'm going to GCF that out to the front. And so for the first term, that leaves me with the 1 minus tan t. And I'm also going to clean up, I have a minus sign and a negative sign, which obviously will cancel each other out. So for the second set, when I pull out the secant squared, I'm left with a 1 plus tan t. All over 1 minus tan t squared. And so on the top, give myself a little bit more room here, the tan t's cancel out. The 1 plus the 1 gives me a 2. So on the numerator, I have 2 secant squared t over 1 minus tan t squared. And that is how we would leave the derivative. Okay, and number 4, again, you can see that this is going to be a chain rule because we have an inside function and an outside function. So the question is, which is which? So the e is always going to be the outside, and the exponent of the e is going to be the inside. So you're going to start by taking the derivative of the e function. And the derivative of e is always just the repeat of itself. So I'm going to rewrite e to the negative sine t. But then I have to say times, and I have to do the derivative of the inside function. So the derivative of negative sine t is negative cos t. And again, you would probably see this written as negative cos t e to the negative sine t, but it doesn't have to be rewritten that way. So I want you to try the next 3 examples. Pause the video. When you're done, unpause the video, and the answers will appear. Here are the answers. Check your work. If you have questions, bring them to class.